Hi, I'm Billy Mainwaring, and I am discussing the sodium chloride and silver nitrate reaction. So, in my presentation, I will be discussing the experimental process that we went through, the results, and then I will also be doing a discussion and conclusion. So, the purpose of the experiment was to identify polyatomic ions, and polyatomic ions are covalently bonding groups of atoms that have a charge. And another purpose was to predict products of double displacement reactions. In a double displacement reaction, one cation from one molecule goes and joins with the anion from another one, so they'll switch. We were also exploring catalytic effect on chemical reactions. And why do we care about my reaction? It allows us to see fingerprints. Sodium chloride is present in most fingerprints, and if mixed with silver nitrate, silver chloride is produced. Exposing the silver chloride to sunlight or ultraviolet light it makes the silver chloride visible, therefore you can see the fingerprints that were left. And it can also be used in photographic paper, although it's not a common use. It is possible. The silver chloride is reduced by photons and it forms an image. So here's more on the double displacement reactions. It's two ionic solutions are mixed, and cation and anion forms a new ion. So as you can see here, these two cations this cation and this anion will come together to form a new one, and then these two mix together to form. Okay, so a little bit about sodium chloride. It's solid at room temperature. It's white. The formula is NaCl. It has a molar mass of 58.44 grams per mole. The anion of it is Cl, and the cation is Na. Properties of silver nitrate. The one that we used was liquid, and it's clear and colorless. The formula is AgNO3. The cation is Ag, and the anion is NO3. So for the experiment, we used 50 milliliters of a 1 ml solution of NaCl, and we added 3 milliliters of the NaCl solution to 1 milliliter of silver nitrate. The reactants produced a thicker white and cloudy liquid with a chunk of white solid that appeared near the bottom. The solution of sodium chloride, the solvent was water, and the solute was sodium chloride. So we needed 1 mole, we needed a 1 mole solution, and the definition of molarity is the moles of solute per liter of solution. So we had to calculate the molar mass, which is the sum of molar masses for each atom in the molecule, and we also had to calculate the grams the molecule needed. So here's some sample calculations. We have the molar mass of Na and the molar mass of Cl, so you add them together to get the molar mass, which is 58.44. And then you multiply that by 0.05 to get the grams that we need, which is 2.92. So the results, this is the reaction that occurred. As you can see, it formed a white, cloudy substance, and there's also going to be a solid that is forming in there. Conclusions. The experiment, we looked at double displacement reactions as we were mixing sodium chloride and silver nitrate together. And why do we care about this? It allows us to see fingerprints, and we can also use it as photographic paper, or use it for photographic reasons. And the formation of a white solid showed us that a chemical reaction did occur because a new substance was created. And then here's some of the equations. As you can see, there's the two cations that are changing places with the anions to form two new.